Good day, everyone. Are you ready to learn? Again, this is Teacher Marlene, and we are going to study the process of simplifying radicals. We are going to divide our discussion into three parts. First, reducing the radicand or isolating the perfect nth root. Second is rationalizing denominator and reducing the index. The focus of our discussion is reducing the radicand or isolating the perfect nth root. Now bear in mind that radical is in simplest form if observe the following properties. 1. If the radicand does not contain a perfect square, cube, or nth root. There is no radical in the denominator or no fraction under the radical sign. And make sure the index of the radical is the lowest possible index. Now, let us recall the numbers that are perfect squares. 1 squared is equal to 1. 2 squared or 2 times 2, that is 4. 3 squared or 3 times 3 is equal to 9. The same with 4 squared, which is 16. 5 squared is equal to 25. 6 squared is equal to 36. 7 times 7 or 7 squared is 49. 8 times 8 or 8 squared is 64. And 9 squared is equal to 81. So the numbers, when multiplied to itself, are called perfect squares. So 1, 4, 9, 16, 25, 36, 49, 64, and 81 are examples of perfect squares. Now let us review the perfect cubes. 1 cube is equal to 1. 2 cube meaning 2 times 2 times 2, that is 8. 3 cube is 3 times 3 times 3, that is 27. 4 cube or 4 times 4 times 4 equals 64. 5 cube or 5 times 5 times 5 is 125. 6 cube or 6 times 6 times 6 is 216. The same with 7 cube, which is equal to 343. 8 cube, which is 512, and 9 cube, which is 729. The numbers 1, 8, 27, 64, 125, 216, 343, 512, and 729 are some numbers that are perfect cubes. Let us see how to simplify radicals by isolating the perfect nth root. Let us look at example 1. Our given is the square root of 50. Now think of factors of 50 where one number is a perfect square. So it is 25 and 2, where 25 is a perfect square. And the square root of 2 is not a perfect square. So getting the square root of 25, which is 5, so we will get 5 square root of 2. This is the simplest form. Now let us have another example. Example 2 given is the cube root of 24. This time, look for the factors when one number is a perfect cube. So we are going to use 8 and 3, where the cube root of 8 is a perfect cube. And the cube root of 3 is not a perfect cube. So getting the cube root of 8, which is 2, then copy the cube root of 3. Therefore, 2 cube root of 3 is the simplest form. Now let us combine numbers with variables. Our example 3 is cube root of 125 m cube n. Since 125 is a perfect cube, let us separate our given into the cube root of 125, or that is the same as 5 cube. Then copy m cube, this is also a perfect cube, times the cube root of n. So cube root of 5 cube m cube is called a perfect cube, when the cube root of n is not a perfect cube. We can determine if the number is a perfect cube if the exponents in the radicals are divisible by the index 3. So getting the cube root of 5 cube m cube, that is 5m. And then you have to copy the cube root of n. So this is our simplest form. Let us have more examples. Our example 4 given is the square root of 125 x raised to 6 y raised to 5. Let us factor our given and separate the perfect square to not perfect square. So 125 is separated into 25 times 5. X raised to 6 is a perfect square since the exponent 6 is divisible by the index 2. Then for y raised to 5, it is separated into y raised to 4 times y. So the square root of 25 x raised to 6 y raised to 4 is a perfect square. And the square root of 5y is not a perfect square. Getting the square root of 25, that is 5, the square root of x raised to 6 is x cubed, that is obtained by copying x and divide 6 by the index 2. The same with y, which is 4 divided by 2. So we will get 5x cubed y squared. Then copy that not perfect square, which is square root of 5y. So this is the simplest form. Now let us have another one. Our example number 5 given is the fifth root of 64 a raised to 5, b raised to 6, c raised to 7. Writing the given in exponential form, since 64 is the same as 2 raised to 6. As much as possible, look for the lowest possible base. So we will arrive at the fifth root of 2 raised to 6, a raised to 5, b raised to 6, c raised to 7. Now let us separate the perfect fifth root to not perfect fifth root. So we have the fifth root of 2 raised to 5, a raised to 5, b raised to 5, and c raised to 5 will be the perfect fifth root. And what is remaining, put that into not perfect fifth root. That is now multiplied to fifth root of 2b c squared. Getting the fifth root of 2 raised to 5, which is 2, fifth root of a raised to 5, which is a, fifth root of b raised to 5, which is b, and the fifth root of c raised to 5, which is c. So we will get 2a, b, c times that not perfect fifth root, which is fifth root of 2b c squared. So this is our simplest form. Well, I hope you learn from my discussions. If that's so, kindly put your comments or if you want to ask for some clarification. And before I end, let me share this quotation. This is related to isolation. So sometimes, isolate yourself because only when the surround is empty, you search within. Thank you for watching. Happy learning!